Welcome everybody, this is Mr. Geiswhite, and here are your 1.2a notes. In these notes we will be simplifying square roots. Now, your bell ringer for these notes has nothing to do with simplifying square roots. It's really just to get you thinking a little bit abstractly about algebra and just comparing, so it kind of relates to what we did yesterday with our comparing and ordering real numbers. So basically, if we have two numbers, x and y, such that x is greater than y, we want to know which of these will be true. Always, no matter what number we choose. So in order to do that, basically what we do is we try to find something that does not work. So let me show you what I'm talking about here. So for x and y, we need a number x that is greater than the number y. So let's just say, for example, if we have 2/3 is greater than 1/2. Okay, 2/3 is greater than 1/2. Now, if we look at A, if we square both of these, if we square 2/3, that's going to end up with 4/9. And we want to know, is that greater than, if we square 1/2, that is 1/4. Okay, so that still holds true. Alright, so that actually did not work out, so let's try another one. Let's look at some negative numbers. So let's say if we have 0 is greater than, let's just say -2. Well, what happens when we square these? Well, 0 squared is just 0, and we want to know, is that greater than if I take -2 and square it? Okay, well, 0 squared, like I said, 0 squared is 0. Is that greater than -2 squared would give you 4, because we have to square that negative also. So this is false. Alright, so I found an example that does not work, so A does not work. And again, we're looking for something that works all the time, not just for some things. We want something that will work for everything. Alright, negatives. Let's see if our 0 and -2 works here. So 0, if we have negative, if x is 0, so -0, which is still 0, is that greater than if I have a negative and then y we said was -2? So if we simplify that, -0 is still 0. Is that greater than, well, here now we have a double negative, which is a +2. And again, this is false. 0 is not greater than 2, so B is out. We actually cannot use our 0 and -2 example here, because 1/0 that's a problem. We can't do that yet. That's something that happens later on in math, but for Algebra 1 we can't do that. So let's look at some other numbers. Alright, so let's say 5. If I say x is 5, that is greater than 2, right? I think we can all agree with that. 5 is greater than 2. But let's see what happens if we make them a fraction. So 1/5, is that greater than 1/2? Well, this is false. 1/5 is 0.2, 0.2, and 1/2 is 0.5, right? So that's like 20 cents is greater than 50 cents. That's not true. So C is false. We're going to cross that one out. So process of elimination, we know the correct answer is D. And it doesn't matter what you do. If we have 5 is greater than 2, and for our x is greater than y, if we multiply both of those by 2, 10 is greater than 4. That's still true. If we look at our other ones that we use to be false in A, B, and C, like 0 and -2, if we double those, double 0, we end up with 0. And if we multiply -2 by 2, we end up with -4. So that's still true. 0 is greater than -4. So it doesn't matter what we choose, D will always be true. Okay, so that would be your correct answer here for your bell ringer. And again, it's not really something that you would expect to see very often. It's just kind of one of these problems that we like to get you thinking on. So, alright, let's jump into the notes there. Again, correct answer is D. So, simplifying square roots. Basically what I wanted to do is just go over this concept of what happens when you multiply a square root by itself. So if you look up here in these notes, square root of x times square root of x, basically what we do is we multiply the numbers underneath the square root, and then that will always simplify to x. So let me show you what I mean here. Square root of 2 times square root of 2 is the same thing as square root 2 times 2. So we multiply 2 times 2, we get 4, so square root of 4, and that simplifies to 2. Next, square root of 3 times square root of 3. Well, 3 times 3 is 9, so we have square root of 9, which simplifies to 3. Next one, square root of 4 times square root of 4. 4 times 4 is 16, so square root of 16, which simplifies to 4. Last one in this column, square root of 5 times square root of 5. Well, 5 times 5 is 25. Square root of 25 gives you 5. So hopefully here you can see a pattern. Well, what happens when I multiply a square root by itself? I just end up with that number. Square root of 2 times square root of 2, all simplified gave me 2. Square root of 3 times square root of 3, all simplified gave me 3. Square root of 5 times square root of 5, completely simplified gave me 5. So what do you think square root of 6 times square root of 6 will be? Well, if you guessed 6, you'd be correct. Square root of 7 times square root of 7 is 7. Square root of 11 times square root of 11 is 11. And the square root of 13 times the square root of 13 is 13. Okay, so anytime you have a square root times itself, it's always just that number on the inside. Alright, now, so what is the simplified form of square root of 25? Well, we just did it on that last page, so we know that the answer is 5 here, right? We know that the square root of 25 is equal to 5. But basically, when we end up with some numbers that are not as nice as 25, what do? That's our question, is what do we do? How do we attack this? And what we're going to do is called a factor tree. So some of you may be familiar with this. If you're not, you don't know what I'm talking about, maybe after I do this you'll understand. So what we do is we take this number and we want to find two numbers that will multiply to give us that. There's a bunch of different ways that you can do these. They may not all be the same, but your final answer will still be the same. 25 only has two numbers. 25 is 5 times 5. Okay? So, going backwards from what we just did in that last example is if we have a pair, of numbers, so we have a 5 and a 5, any pair that you have comes out as one single number. So our final answer here would be 5, which we already know that. We did that right there. So some of you are probably still like, I don't know what's going on. Let me try and clear it up here with some more examples. So square root of 60. The first thing we want to do is we want to take the square root of 60 and we want to break this down into two factors. Okay, so you need to write down two numbers that multiply to give you 60. There are a bunch of ways you can do this. 2 times 30, 3 times 20, 5 times 12. They will all give you 60. What I'm going to use is probably one of the more obvious ones, which is just 6 times 10. Okay, 6 times 10 gives me 60. If these numbers can be further simplified, we need to do that. Well, 6 is not all the way simplified, so 6 is 2 times 3. Now those are simplified. 2 times 3. 2 would just be 2 and 1. That doesn't help. 3 would be 3 and 1, so we don't want to do that. That doesn't help. Now what I would suggest you do is come back here. Since we took this 6 and we broke it down, I'm just going to cross that out so I'm not tempted to use that in my answer. Because we don't have 6 anymore. We have a 2 and a 3. Okay? 10, we only have one option for 10, and that's 5 times 2. And again, same thing. I'm going to cross out this 10 so I'm not tempted to use it in part of my answer. So what I need now are the pairs. Well, which of these numbers has a pair? Well, I have a pair of 2's. I have a 2 there and I have a 2 there. Any pair that you have comes out of the square root, so it's no longer underneath the square root. The numbers that do not have a pair go back underneath the square root and they get multiplied back together. So 3 times 5. So my final answer here, I had a pair of 2's, so that comes out. And then square root, 3 times 5 gives me 15. So that is your final answer for this example. Okay, we're going to do a couple more of these together, so if you're still a little unsure, we got a couple more to do. Next, square root of 200. Now, this one, again, has a lot of options, but I'm going to choose probably, hopefully, one of the more obvious ones. 2 times 100. Now, keep in mind that we are always looking for a pair. We're looking for a pair of numbers. Use that information to help you break down these numbers further. So 100, well, we could do 25 times 4. We could do 50 times 2. But if I'm looking for a pair of numbers that multiplies to give me 100 would be 10 times 10. I'm going to scribble out this 100 so I'm not tempted to use it later. Now, the reason why I chose 10 times 10 is we do not have to break this down further. 10 is 2 times 5. That's correct. 10 is 2 times 5. But I'm looking for pairs. That's the whole point here with these square roots is we need a pair. I have a pair. I got a pair of 10s. There's a 10 and there's a 10. It comes out. It does not have to be a prime number. Okay, we don't have to go down to 1, 2, 3, 4. I'm sorry, 1, 2, 3, 5, 7, 11. Like whenever you have a pair, you're done. So that pair comes out as a single number. The numbers that don't have a pair get left underneath your square root and multiplied back together if you have more than one. But in this case, we only have that 2. So that's your final answer there for C. D, 294. Sometimes you're going to come across these numbers that are not as familiar to you, so you want to just go through and find a number that will divide out. Okay, so I know this is an even number. 294 is even. So what I'm going to do is I'm going to take 294 and I'm going to divide that by 2. So 2, and this ends up being 147. So that kind of helps me to break that number down a little bit to make my numbers a little bit smaller. So now 147, we need to divide this by some numbers until we find out which ones will go in evenly. So I'm going to do 7. Alright, so 147, this gives you 7 times 21. Okay, 7 times 21. Now 7 we can't do anything else with because 7 is prime, so that's just 7 times 1, so we leave that alone. 21 can be broken down even further. This is 3 times 7. Okay, I forgot to scribble out my numbers, so I'm going to come back and scribble that out. Scribble out the 21 because we broke that down further. So what are my pairs? Well, I have a pair of 7s. So the 7s both come out of the square root. Whatever is left over stays underneath and gets multiplied back together. So square root of 2 times 3. Multiply those numbers together. 2 times 3. Bring the 7 down. Bring that 7 down first. Square root 2 times 3 gives you 6. So there's your final answer for example D. Alright, now for the next one here, E, what I want you to do is pause the video, go through the factor tree for 90 and see what you get. We do have some extra stuff out front here. We have a -2, and I'll talk about that. But what I want you to do, pause the video, do the factor tree for 90, and then come back and see what you have. Okay, so hopefully you paused the video and actually went through and did that, but if not, you can just follow along with me here. So 90, I'm going to use 9 and 10. 9 can be broken down further. That's 3 times 3. I'm going to scribble out the 9 so I'm not tempted to use it later. And 10 can also be broken down into 2 times 5. Now, what you don't want to do is you don't want to be tempted into using like this 2, the -2 that's out front here. That doesn't have anything to do with the numbers under the square root, okay? So we're going to ignore that for our factor tree part, but then that will come back into play later. Alright, so what are my pairs? Well, in this case I have a pair of 3s. So that will come out. The 2 and the 5 will be multiplied back together and left underneath the square root. Now, a lot of times what people forget is that we did have something out front here that needs to be out front of our square root. So I'm going to bring down the square root of 2. But now, since I had a pair of 3s, that also needs to come out. So times 3, and then square root, whatever does not have a pair, gets back multiplied back together and left under the square root. So 2 times 5, they did not have a pair, so they stay underneath the square root. So let's multiply. -2 times 3 is -6. Square root 2 times 5 is 10. So there is your final answer for this example.